Okay, everyone. So today we are very pleased to have Vijay and Satya from HCLTech with us. They're going to be describing the use of EdgeX, how they use EdgeX to address their edge use cases. Vijay is a technical specialist at HCLTech, and joining him is Satya, who is a solution architect at the company. Now, this should be really interesting because I know HCL have got some good experience already with EdgeX, and they've now even gone further and are beginning to push code back to the EdgeX open source code bases, which is great. So yeah, let me pass you straight over. Vijay, Satya, who shall kick us off?
Yeah, thank you, James. So I will just start sharing my screen. Okay, let me start. So, hello everyone. So myself Vijay from HCL Technologies, and along with me Satya is also there in this call. So in this session we will talk about our team, how we started using EdgeX, then our roadmap and our contributions with the EdgeX. So this is what we will be covering in this session. And see about us. So our team's name is EPL, so Embedded Platform Lab. We are actually a COE team. It means Center of Excellence team. So we offer our services to the delivery teams. As you can see here, our delivery teams, they come from various domains like medical, aero, auto, industrial. Okay, so these delivery teams, they are our internal clients. Okay, and they in turn interact with the external clients. So whatever input we get, that is only from these delivery teams. Okay, so our scope in software from edge computing perspective is limited mostly to the constrained edge gateway and the smart edge gateways. Okay, and we focus mostly on the embedded software like industrial protocols, Linux, RTOS, or bare metal programming, firmware programming. So these are all the areas normally we focus. And our team size is 6 for now. And coming to our objectives within the HCL, so our objectives include as a COE team, we should be developing capability in the emerging areas. Okay, along with that, we should also develop SMEs by improving the capability as well as by doing some POCs. Then development of reference architectures. Okay, so these delivery teams, sometimes they might be needing some kind of accelerators from us, which speed up their work for the external client. So for that, we will be developing some kind of reference architectures. Okay, and then open source contribution. So whatever technology that we are focusing on, that we are learning in that technology, so we are expected to do open source contribution. Okay, and finally, the delivery support, the support to these delivery teams in terms of consultation, or sometimes we will get deployed in their projects and we will work, and we will also help them with the accelerators, as I said, through reference architectures or development of POCs. So this is how we operate, and these are all our objectives. Okay, and so now I am going to tell how we actually started using EdgeX. Okay, so as I said in the last slide, so we used to get requirements or support from these delivery teams. Okay, so when we maybe some 2 or 3 years back, we have got various requirements for various support. Okay, so but all of these guys expected us to develop some kind of wireless gateway. Okay, so everybody seems like moving from wired to wireless protocols. So they want some kind of wireless gateway. They also expect that needs to be a open source one. Okay, and so since we are part of embedded software development team, mostly the requirements came around in the area of the device services or device connectivity layer. with the various new protocols. Okay, and sometimes they ask us to develop some kind of POC, and we might need to showcase our capability on behalf of HCL to the external client. Okay, and finally, as I said, this reference framework development, we need to develop this reference framework and we can deliver that to these delivery teams. Okay, and they will finally in turn they will give that to the external clients. So those clients basically they are interested in some kind of IP development. Okay, with that reference framework from open source. Okay, so this is what this is the start of our work on this IoT and edge computing area. So as soon as we started seeing the trend, we came to a decision and we started developing this wireless gateway requirements. As you can see here in this diagram, so this is what we have started developing the wireless gateway. See, all whatever you have seen here, all these things have been developed by us. Okay, so none of this is from open source. Everything we have developed. Okay, so major as a POC, what we did was we developed these basic services and we tried to communicate using these services to the end sensor device through the protocols like REST and Thread. With these protocols, we started our work. Okay, and some of the things we did not develop. So we developed this temperature application, light application, then this device connectivity layer, this data aggregator, command processor, all those things we developed. But obviously we faced problems because the bandwidth, the timeline we had was very low. Of course, we faced problems. We faced some architecture issues, and it took a lot of time for us in finalizing the requirements, and even the design. We took multiple iterations, especially this one. We did not have much time to implement the non-functional requirements, the scalability, security, performance, all those things. Okay, so these are all the problems we faced when we attempted to develop all the microservices or all the modules for this wireless gateway. Okay, so this is where we started exploring further. Finally, we encountered this LF Edge, EdgeX, and Fledge. Okay, it also, as I said, one of our job is also to look for the emerging areas. Okay, and when we saw EdgeX, we tried to use it, and we found that EdgeX solves most of the problems, whatever we have listed here. Okay, so then we decided to put most of our efforts in this area. Okay, so in the past 2 years, with EdgeX, so this is what we have contributed to our delivery teams within HCL. If you see here, these are all the POCs that we have done. So I will be giving the demo for all these 3 things. I mean, for the last one, I will be giving the demo. For the other 2 POC, I will be explaining in the subsequent slides. Okay. Apart from this POC, for this capability development and team ramp up, training to the delivery teams. So these are all the things that we have contributed internally to our delivery teams. And this is what we have contributed so far to the EdgeX community. If you see here, as I said, one of our goal is the open source contribution. So we started our contribution by doing some small bug fixing. Okay, then we started involved in the QAP review, and some 1 month back we completed our contribution on UART device service. Then sometime back we completed the QAP device service, and now almost we have completed. We have initiated the code review for the REST device service. See, this objective is mainly with respect to forming the wireless gateway with all the protocols. So going forward, we are also expecting to develop services on BLE services, ZigBee, and any other wireless protocols. Okay, so this is what we are planning. So from open source contribution as well as from wireless gateway perspective, as soon as we develop something, so we will be contributing back to EdgeX. So this is what we have done in the last 2 years. And now let me go. Okay, fine. And this is the expectations for us going forward from EdgeX. Okay, so as I said, this for open source contribution, we will be actively looking for this device services layer. So as this is our primary skill set, which is embedded software development on various industrial protocols. And from this wireless gateway perspective, we are expecting all the services needed for this wireless gateway, which includes this IPv6, multicast, low power device management. Because we remember sometime one of our delivery teams was asking us, checking with us whether with EdgeX it supports IPv6 with multicast features, whether it has any specific features for this low power device management and all. Okay, so the point is, so those delivery teams will check with this, and sometimes when the requirement drops, then they will change their plan. So they keep on checking with us. So it purely depends on the external client, so how they are taking decision. But from our side, what we have done is we have captured all the requirements, at least from the infrastructure piece, from the non-functional requirement perspective. Okay, so these are all the functionalities we are expecting from EdgeX going forward. Okay, so this is our expectations, and as you see here, this is our first POC. This is done for one of our industrial customers. If you see here, we used the EdgeX. We tried actually to emulate the industrial condition monitoring system. So what we did was, as you can see here, we took a Raspberry Pi and we deployed EdgeX in the Raspberry Pi, and we used SHT20 temperature and humidity sensor. We connected this sensor through Modbus. Okay, we used Modbus device service. Okay, and this is on the southbound side. So once the data has obtained from the end sensor, it will be sent to the northbound cloud. In this case, we use this IBM Watson cloud. Okay, and also whatever data that we have received, we did some minimal analytics using rules engine. Okay, and what we actually did was we found like we did some kind of calculation, like if the temperature falls below some threshold, or if the temperature exceeds the threshold, we toggled some LEDs. You can see the LEDs here in this breadboard. Okay, so this is what we showed to one of our industrial delivery unit customers. Okay, and whatever screenshot you are seeing here, all these things are temperature value which has been recorded from the IBM Watson cloud. Okay, so this is one use case, and another one, as you see here. So this is the ask from one of the medical customer. So he asked us whether we have any experience in patient monitoring system. Okay, so if you see here, this is the hospital environment. So what we thought was, why don't we use EdgeX, and we can deploy EdgeX in a gateway. So as you see here, these red boxes, all these red boxes are like a gateway. Okay, so we can deploy EdgeX in this gateway. Okay, and also if you see here, there will be a remote tracker device. This device will be there with all the patients. So wherever the patient travels, this remote tracker device communicates with this gateway through BLE communication. Okay, for this also we used BLE device service from EdgeX. Okay, so what actually it does is it communicates with the tracker device, and it records the patient's vital signs like heartbeat, temperature, pressure, even the location of the patient, all those things. So it will get all those things and it will pass the data to the cloud. So you can see here. So in that case, these are all clinicians or doctor. What they can do is they can monitor the patients remotely. Okay, by sitting in some centralized location. Okay, and this also enables the patients to move, to roam around the hospital wherever they wish. Okay, and also if you see here, this is one patient who fell down, who fainted down, and this can be monitored remotely. Okay, here some patient has not moved for a long time, and this will send some kind of alert. Okay, that alert also we can be able to receive it in our personal phone itself. Okay, so for this also we used Raspberry Pi only. We used the Raspberry Pi and we used our normal phone itself to send some emulated data for temperature. Okay, here the cloud we used was the UB.'s cloud. In the last POC used IBM Watson, so here we used UB.'s cloud, and in the cloud there were some features like for alert, sending SMS and email. So those features we used. So this was the POC we showed for our medical customer. And the third one, so this is one of the ask from the customer. They actually wanted to control the remote device. Okay, they wanted to take control of a medical device. Okay, basically they wanted to send keyboard on mouse events from a remote location, so that they will be able to control the medical device. So this is a video. I will play it. So maybe I will. So if you see here, we used a Raspberry Pi. Okay, so this test server is nothing but Raspberry Pi, and inside the Raspberry Pi we have installed this EdgeX. Okay, and this is the DUT. This is the medical device. Okay, and also we used a HID emulator. Okay, what it basically does is it receives the mouse and keyboard events serially from this Raspberry Pi through UART, and it converts the corresponding events into the actions of keyboard and mouse. Okay, so this test server, this emulator, this DUT, all these three things are in the same location. Okay, so this is the remote PC. From this remote PC, we would be sending the required mouse and keyboard events. If you see here, we tried to recreate the setup here. So this is the laptop. So this laptop acts like the DUT, this remote device. You can see here the Raspberry Pi. Okay, and here there is a small device. So this device is this HID emulator. Okay, see now. So that's what I've been explaining in that video. And so this HID emulator is connected to the DUT and Raspberry Pi serially. From the EdgeX side, we used UART device service for this. Okay, and so let me skip. Okay, so basically what we are going to do now is, so in this laptop, so this is the device under test. In this laptop, I will be opening a notepad. Okay, a notepad will be opened in this laptop, and from this Raspberry Pi, I will be sending the keyboard and mouse events. Okay, then what happens is, whatever events that keyboard events that I have sent, that will be transferred through this emulator, and finally all the events will be, the corresponding actions for that events will be happening in this laptop. So in this case, without myself using the laptop keyboard, you can see the text getting printed in the laptop's notepad. So here I am starting the EdgeX stack. So now I am starting the application that we have written on top of EdgeX. Okay, and so this is the command we will be sending from remote. If you can see here, these are all various keyboard and mouse events. Okay, that command will be sent from the remote PC. There is a application running inside this test server, I mean this Raspberry Pi. It will receive that command, and those values will be sent to EdgeX UART device service. So that will forward that event to HID emulator, and the corresponding text will get printed in the notepad in the laptop. You can see here. So I'm sending that command. In the video here, you can see once the command is sent out, you can see here that blinking of LED on the HID emulator. And also I have taken my hands off from the keyboard. Okay, you can see here in the notepad, all the events that we have sent from the remote PC that is getting printed in the notepad through this HID emulator. Okay, so this is on the keyboard side. So similarly, we have done for the mouse also. So that is pretty much the same. So I wish I should have enabled the audio for this so that you would have got a good experience on this demo. Okay, so that's it from our side. So if you have any questions on this.
Hey, Vijay, really good presentation. Thank you. Great update. I was glad to see it coming together. You mentioned you've got these 3 PLCs you talked about.
Right.
One with the temperature, one with the patient monitoring, and then this emulator.
Right.
Are any of these now in production, or is it all at this point kind of POCs with your customers?
No, all these things are just our capability development, and still it stays in POC. So nothing has gone to production yet. Okay.
And you mentioned that you had also looked at Fledge. Can you share with us, especially since EdgeX and Fledge are part of LF Edge, can you share with us kind of what your thoughts, why EdgeX versus Fledge?
Okay, fine. So initially when we started looking at all the frameworks from LF Edge, so this EdgeX and Fledge seems to be solving all our problems. Okay, in parallel, we put our efforts in both in EdgeX as well as in Fledge. So fortunately, the scope for open source contribution was more for EdgeX. Okay, so we actually then we started putting more efforts in EdgeX, and also we came to know from one of the documentation this Fledge is more useful in IIoT kind of environment. Okay, this EdgeX is more used in some kind of consumer products, such kind of environment. Okay, so we thought this Fledge is mostly used only for IIoT environment, but we also did some kind of POC there. Okay, but it did not go well. So since, as I said, the scope was more on open source contribution, that was more for EdgeX. So we put most of our efforts only on EdgeX. So I hope that answered your question, or
It did. Thanks, Vijay.
Yeah.
I guess last question is, I noticed you said you were using the Bluetooth device service.
Yes.
My understanding, and community, correct me if I'm wrong, I thought our Bluetooth device service was not available right now. So do you have a new one? Is that something you plan to contribute back?
We have plans to contribute back. So when we checked that BLE device service, we came to know only the advertiser part was implemented. The other part was not implemented. And also when we were checking from the security perspective, some of the features were not there. This is what we found. So normally when we find these kind of things, we used to check with Jim or Ian. Okay, even for BLE device service, we initiated a discussion with Ian, saying some features were not there. Then that was we did not continue that. But yes, we have noted that. So there is still some scope for improvement for this BLE device service in EdgeX. So hopefully in the coming days, we will be able to contribute more and make it a complete BLE device service.
That's great. Thanks so much, Vijay. Really nice presentation, and really so happy to see you guys using it.
Yeah.
It is great, isn't it? Yeah, thank you both. And I really appreciate it, especially considering the time already over there. So it's already late for you, isn't it? So thank you so much for staying on and doing this for us. Any other questions for the guys here? My comment was going to be that I really like how you extended the platform where you thought it needed new features. I'm quite interested to hear in your kind of suggestions for roadmap and stuff like that. So we'll maybe do a session offline on that one. But really good. Thanks again, guys.
Yeah, thank
really
you.
Appreciate it. Thank you.
Thank you. Thank you, everyone. Thank you.